Intermolecular attractive forces. There are 7 types that we need to be aware of. We have ion-ion interactions, where these are very strong. Why? Because it's pretty much ionic bonding. We then have ion-dipole interactions, where here we have something like, say, a sodium ion interacting with something polar, such as water. Ion. So recall that oxygen has partial negative charge, so therefore that will be attracted to the sodium ion. We then have dipole-dipole interactions, where you'll have, say, let's go with something polar, such as ethanol, where we have once again a partial negative charge that could be coordinated to, say, the hydrogen on a water. Notice that we have 2 polar compounds, and they are interacting with the charges on each other. This, of course, could also be referred to as a hydrogen bond, where the electronegative atom on one molecule is coordinating with the hydrogen of the other. So, in other words, hydrogen bonding is a type of dipole-dipole interaction. Alrighty. Next, we have the dipole-induced dipole. So this is where something that does have a dipole, such as, we'll continue with ethanol, is interacting with a molecule that does not usually have a dipole, such as, say, bromine. So bromine will look something like this. As you can tell, both are the same electronegativity, but because of the partial charge next to it, it's going to form a induced dipole where all the electrons shift to the left, and we end up with a charge. So let's depict that. Partial negative, and therefore this end will be partial positive. It is an induced dipole, as there should not be a charge, but it occurs anyway because another charge is nearby. Alright, the last one is the instantaneous dipole along with an induced dipole. So if an induced dipole seems kind of a spontaneous thing, it is, but the more spontaneous one is an instantaneous dipole. This would be when, just by chance, say with the previous example of bromine, there are the electrons around the bromine, also along the bond. All of these electrons shift just by randomness more towards one bromine than the other. That is going to give a charge onto the bromine, where the bromine with the more electrons is going to be partially negative, and the bromine on the other is partially positive. That will then go and interact with other things, and because it has this partial charge, it can now induce dipoles in other things and then cause an interaction along with it. Right? Now, why did we cover intermolecular attractive forces? Well, these have a large implication in the physical properties that we see in organic molecules, which will be the topic of the next video.